So this is my modular battery pack, and I'm just doing a quick video to show how I went about it, because a lot of people were telling me that it was a terrible idea, that it wouldn't work. And I have a friend who wanted to know more about it, so I figured I would do it. As you can see, it's a little pouch that comes apart with Velcro. Now obviously that part is completely custom, that's not what the battery is about, but it made a little nice carry case. So my requirements were essentially I wanted high current output. This is a number of years ago, so these are A123 lithium iron phosphate cells. Now these are 1.1 amp hour cells, which means that they can output about 10 amps because of the quality of the cells. Nowadays that's nothing really to write home about. You could easily get a 3 amp hour cell in the same size that can output
10,
maybe
15
amp hours without too much trouble.
15
amp hours if you're okay with some heat, and you know what, probably even more, to be honest. I haven't looked at it in the last couple months, but it's been changing so fast that like I know this is easy to replicate at this point. However, the other thing I wanted was the fact that lithium iron phosphate cells are incredibly stable. I don't think I've ever heard of one of them even venting, and its thermal runaway is quite unimpressive. In fact, lead acid batteries are probably more unstable than this stuff is. So that was part of the reason, just because the fact that it's a modular pack lends it to being lugged around for troubleshooting stuff. I have a friend whose mill needed its auto feed motors tested, so it needed 90 volts. So it's just a matter of putting, you know, these 6 12-volt packs in series, and that gave him 80 volts, which was enough to test. And the fact is also that these lithium iron phosphate cells, the voltage stays a bit more stable, and they are better stand-ins for lead acid batteries. And again, since the goal of this was to have kind of a little universal a testing pack for troubleshooting things, but also just for running my small scooter for very, very short assist periods, these were the right cells for my use. That being said, nowadays definitely go with some Samsung or some LGs, get some 3 amp hour cells in there, no problem, it'd be way better. So what's so different about this? The big thing people kept going on about is how, you know, the pins are going to melt, it's not able to take the current, blah blah blah. And so I'm going to take apart one of these packagings I made. So first off, I didn't just use any cheap old cell holder. I'm going to have to find the information, and I'll put a link down under the video, but I had found a specialized device where essentially they gave, first off, the specs were incredibly well detailed, and if you went just from volume and surface area on these gold-plated terminals, I'll just remove these 3D printed caps I made. I was getting something, I don't remember quite what I was getting. I think it was the equivalent of 18 gauge or something like that, which over the distance it's going, 10 amps is not a problem at all. You can probably do quite a bit more than that. I mean, the longer the distance, the more resistance you get, but really over such a short distance of about 1 inch or 2 centimeters, you know, 18 gauge is more than enough. So I've got these balance leads on there. This is like I said, 12-volt pack in series. Yeah, so just as a proof of concept, what I'm going to do is I'm going to fully charge this, and then I'm going to discharge it and look at what the heat output is, just to see how well it worked out in theory. I mean, in practice compared to theory. So the problem often with the standard ones is they come out as a tiny little pin, and they go down to a very, very fine point, and that's where the heat concentrates. Well, that's not true. That's where the heat has its effect, because that's where you don't have enough material to dissipate the heat. So let's start testing this. Alright, so I found a way to test the load of the battery. I've got this little 26 gauge nichrome wire. So I've got 5 inches here, which will draw approximately 10 amps at 12 volts. Got a block of ice to keep it cool so that the resistance doesn't drop too much. I want to keep the nichrome wire resistance fairly stable. So just to get started, we've got the battery, not really visible. Everything's at around 5 degrees Celsius in here. Wire is at around 10 because I was holding it in my hands. Ice minus 21. All right. Yeah, that's not working. Let's increase the resistance on that.
And from there, I'm going to use the video recording to figure out how much current's been used total.
12 degrees. So are the batteries. It's just the relative difference. That's just because it's closer to cold stuff. Tabs aren't warming up any more than the batteries are.
So by the end, the resting voltage was at about 12.6 volts, which is below empty. And so that would mean that we would have been drawing at least 10 amps since it lasted 6 minutes. And as we can see, the batteries have gone up to about 15-20 degrees. And the tabs are significantly colder, so I wouldn't hesitate to use this in a high current pack. These are very low internal resistance cells, so the holders are not the limiting factor here. Well, I hope this was helpful to you. Please like, subscribe, check out my other stuff, and I'm glad my calculations weren't too far off.